of the MPO Tech August 6th meeting to order. Can I get a motion for approval of the agenda?
So moved. Mark Miller.
Sturms, second.
All right, we have a motion and a second. The way we've been doing this is we will not have everybody turn their mics on and say aye. If there's anybody that's opposed to the motion, then we'll give a moment for that. Otherwise, we'll consider approved. So is there anybody that is opposed to approval of the agenda? All right, with that, we'll consider the agenda approved and move on to approval of the meeting minutes from the June 4th, 2020 meeting.
Motion to approve the minutes, Huesman.
Burgesser, second.
All right, we have a motion and a second. Any further discussion? Anybody opposed to the approval of the meeting minutes? If not, we'll consider them approved. Next up, we have a presentation assessing the ecological state of 4 Mile Creek and Walnut Creek. I believe, Allison, you're going to do the introductions.
Yes, thank you. We've invited Dr. Peter Levi here of Drake University to present on some of the innovative work he's doing along both Walnut Creek and 4 Mile Creek, so both the western and eastern side of the MPO planning area. And so, Peter, I'll let you take it away from here.
Great. Thanks, Allison, and thank you everyone for this opportunity to present some of my recent work and ongoing work in the metro area. As I told Allison, we have a lot of data, and I do want to keep this short to 15 minutes or less and allow a little time for questions, but also give you enough context that you can appreciate some of the things we're doing and understand how it fits into the broader picture of our social and economic health, as well as our ecological and environmental health here in central Iowa. So Dylan, I think, is going to be advancing slides for me, so hopefully we have that timed okay. I'll say at the top here that these are just results from our first year of a 3-year study. So this is preliminary, and I'd love to talk to anyone in greater context at any point. So I have my email on there. You can find me on the Drake University website as well. So please don't hesitate to reach out to me to continue any discussions that some of these data might spark or questions that might come to your mind. As Allison said, we're looking at both the east side and the west side of the metro. And Dylan, if you want to advance the slide. I do want to start out by thanking all of the communities and organizations that have provided funding and support for this research. So this is a really fantastic opportunity for us at Drake. I'm training a lot of undergraduates in ecological monitoring and restoration work. And this wouldn't be possible if it wasn't for the strong support through our watershed management authorities and the funding from all of the organizations and municipalities you see listed here. So I wanted to start out by thanking many of you are from these municipalities as well. So thank you for this opportunity. So I wanted to provide a really brief primer in stream ecology. Why should we care about streams? I see them as a circulatory system of the landscape, right? So they're moving water and much more across our landscape, providing a lot of different services to us. They're providing water, they're providing fish, they're providing flood resiliency and reduction as water moves down them. And so when we typically think about streams, we think about what's going from upstream to downstream, and we think about what's coming in from the surrounding landscape. So these factors are dictated by land use and the climate of the region. Next slide. As a stream ecologist, though, there's more appreciation now for what's actually happening in the stream, right? These aren't just passively moving water and sediment downstream, but rather there's a lot going on within a stream reach itself. And so we can measure a suite of variables such as physical measurements, like how long does water reside in a given reach, like represented by this box here. I will say I did have to go to a picture of New Mexico to find a somewhat pristine prairie stream. So of course we don't quite have those mountains here in Iowa. But in a natural system, there's inputs coming into a reach from both the landscape as well as upstream. And we can measure, again, the storage. We can measure the chemistry of the water. We can measure the biology or what's in the water. Next slide. And of course, there's a lot happening within that reach rather than just those snapshots of what's the chemistry right now, what organisms are there right now. And one thing that we do in my lab is measure the function of the stream. So in that way, we can measure the metabolism, or how much energy is produced and respired by the organisms living within it. And that gives us a tab on how healthy that stream reach is. So I'm excited to share with you some data at the very end of the presentation on the stream health of 4 Mile and Walnut Creek using these integrative metrics. Next slide. That was a pristine stream in New Mexico, as I said, a pristine prairie stream. And we know here in Iowa, we have a lot of land use change. So when we change the landscape from a more natural prairie system to agriculture, there's a lot of things from those boxes that I just showed on the last slide that can be modified. So the riparian area is different. That's the area along the side of the streams. The channel geomorphology, or the shape of the channel, the physical shape of the channel, could become much more simplified, just now trying to move water off the landscape and keep it going downstream. So channels are often straightened. There's often flashy inputs following storms. So water can travel much more quickly from the landscape into the stream. And so we see peaks in discharge that occur more rapidly after the landscape's been modified. We often measure elevated nutrients, so there's more nutrients being put into the system, and all of those different physical and chemical aspects have an effect on the biology. So we may have less diversity, or we have less organisms overall. Next slide. That can also happen in urban systems. So the same things happen in urban systems as might happen in agricultural systems, sort of pushing that stream ecosystem to altered or impaired state, because these are different conditions than what would otherwise normally naturally occur. Next slide. So what we're studying in 4 Mile and Walnut Creek, going back to that box and arrow diagram I showed you, how does land use and climate or season affect these different aspects within a stream reach? And also, and so that's question 1 here, how does water quality vary across different land use types, agriculture, suburban, urban? How does water quality vary across seasons as well as years? So we're coming into a drought here. We've been in a bit of a drought. Our stream levels are really low right now. So if next year is a little wetter, last year was more normal, I'd say, in terms of discharge. So we're going to be able to compare how do these streams, what's the health of these streams as we experience wetter or drier years. So that's sort of the first set of questions. The second set of questions is what factors most strongly influence stream health? So by measuring a whole suite of physical, chemical, biological metrics, we will be able to pinpoint, is it the discharge? Is it the nutrient levels? Is it the algae? Or is it some combination at each site that dictates the health of that particular stream reach? So that'll be exciting, more so at the 3rd year of our study, to be able to assemble all our data and look at that. And then finally, you can see I added this red box into my box and arrow diagram, the restoration box. So there's so much happening in the metro with stream restoration, with the Central Iowa Water Trails, all super exciting. And so we will be able to use our data to assess whether these management practices, such as saturated buffers or stormwater retention basins or wetlands, are improving or changing the health of the stream. So that's another exciting question we'll be able to start to answer after 3 years. And I'm looking forward to having that full data set. Next slide. Next slide. Yep, there we go. So I wanted to quickly show you where our 3 sites in each watershed are. So as I mentioned, we're studying the effect of agricultural, suburban, and urban land use on stream health and water quality. And so we identified 3 locations in each watershed, one to represent the agricultural headwaters of 4 Mile Creek and Walnut Creek, one to represent a more suburban land use and one to represent an urban land use. And you can see with these zoomed in Google images how that land use changes. Our study reach and our water quality station is at the downstream end of each of these colored boxes that I'm showing, the blue, orange, and black. And I could be more specific about those sites, but I just wanted to give you an idea of where those are. And next slide will show the same sites in Walnut Creek. So we have a site up in Urbandale at 156th and Waterford Road. The suburban site in Clive is at 128th, just south of Hickman. And then our urban site is at 63rd and Grand, right at the border of West Des Moines and Des Moines. And you can, again, with these zoomed in pictures, really see how land use changes drastically in relatively small watersheds. That's why I often say in my presentations that there is no better place in the country to measure how these human-dominated landscapes like agriculture, suburban, and urban landscapes influence water quality than here in central Iowa, because we have those rapid transitions between these very different land uses. So this is a really exciting project that can inform a lot of knowledge much broader than central Iowa. Next slide. What I wanted to share a little bit of data now that I provided some background to our study. And the first thing I wanted to share is a little bit of the physical data. So we can calculate the flashiness. And remember, flashiness is how quickly does water go from the landscape into the stream after a storm event. So if you think of a area that has a lot of impervious surface, a lot of parking lots, a lot of buildings, water is going to flow off of that into stormwater sewers and to a stream very quickly, relative to a part of the watershed that might have more soil or prairie where the water can infiltrate into there and move via groundwater flow much more slowly. So we calculated a flashiness index, which is known as the RB index. And I didn't want to get too much into the details, but rather show you the data. And this is our urban site in 4 Mile, just north of the Scott Avenue Bridge. This was September 3rd of last year. So the stream was only 2 meters wide. I have it set up there to measure discharge. And then a week later, Dylan, you could advance the slide. A week later from the same place, discharge had increased 7,000-fold. So in early September, we had a big rain event in the metro. So this is from September 10th, just 1 week later. So urban and agricultural systems are often more flashy. If you go to the next slide, Dylan. Thank you. The trick with measuring flashiness, though, is that you need a good, decent-sized data set. So what we did is we looked at the USGS gauging station. So USGS, the research branch of our federal government, has been measuring stream discharge at several sites in the metro for more than 30 years, which is really beneficial. Sorry, the 4 Mile site in Ankeny has only been 20 years. And what I wanted to first show is Beaver Creek. So Beaver Creek is primarily, it's a larger watershed than 4 Mile and Walnut. It's primarily agriculture. So again, there's more soil for water to infiltrate into. And you can see that flashiness from about late 1950s until 2019, flashiness has not changed. So the speed with which water goes from the landscape to the stream after storm events has remained relatively constant. It's not a significant relationship, but you can see with that dotted line I put in, it does go even slightly down, but I'd say that there's no change in flashiness in the Beaver Creek watershed. You could advance the slide, Dylan. So now you can see the other watersheds that are here in the metro. You can see Walnut Creek in the upper left has had an increase in flashiness. The USGS gauge here is at 63rd, just north of Grand Avenue. So right, again, at the border between West Des Moines and Des Moines. And you can see that Walnut Creek has become more flashy, which means water is traveling more quickly from the landscape to the stream after a storm event. For 4 Mile in Des Moines, that gauge is, I believe, at Easton Boulevard. I'd have to double check, but you can see that flashiness for the more metro part of the 4 Mile watershed has remained relatively constant since the late 60s. So flashiness has not increased for Des Moines, 4 Mile in Des Moines, whereas with the orange points you see in the lower right, flashiness over the last 18 years in Ankeny, that USGS upstream gauges just south of Ankeny, it has increased. So again, water is moving more quickly from the landscape to the stream in both Walnut and 4 Mile at the middle of the 4 Mile watershed. So these data suggest that that development has increased flashiness, or landscape change has increased flashiness in those watersheds. One thing that I think about with 4 Mile in Des Moines, we don't see a change since the late 60s. One thing that these data suggest is maybe you can see the flashiness numbers are already as high as where Walnut is going up to. And so it could be that once the USGS started measuring discharge in Des Moines on 4 Mile, we were already at a certain level of flashiness because the city had already been developed. So that's one thing that I would suggest from those data. Next slide. So then just a little bit of chemistry. Here we can see chloride data, and I wanted to thank Jeff Mitchell and the lab at Des Moines Waterworks for assisting us with running these samples. You can see 4 Mile, the 3 panels on the left are for 4 Mile, the 3 panels on the right are for Walnut Creek. The top 2 panels are concentration, so how much chloride is in a liter of water. And for the next few figures, I'll be showing the agricultural site in green, the suburban site in orange, and the urban site in gray. And what we see on this pattern is that chloride is pretty constant and low in both our agricultural sites. But for both the suburban and urban sites, particularly the urban sites, we see that chloride is highly variable, and it ramps up to especially high concentrations in the winter. So of course, this is associated with all of the road salt that we need to apply during the winter precipitation events in order to maintain safety and keep people from sliding all over the show in their cars. So we can see that clearly in the data that there is this big jump in chloride at the suburban and urban sites. The middle panels are the load of chloride. So how much chloride is going downstream per day. So what concentration fails to account for is water volume, how much water is in the stream. And we know that discharge increases downstream. So there's more discharge at our urban sites. So you can see again, load is pretty variable, and it gets quite high during even the summer storm events. So you can see the highest points are not at winter, but rather because flow is relatively low in winter. And then finally, the bottom 2 panels are the yield. So how much chloride is coming from the upstream watershed per hectare. So again, you see that it's predominantly driven by the urban and suburban sites. So next slide will show the exact same patterns, but for nitrate. So again, if we look at the top, that's concentration. Really clear seasonal patterns that the highest nitrate concentrations occur in June, and there's a precipitous drop to July and August when nitrate's very low. That's when we have a lot of plants growing on the landscape and warm temperatures, so nitrate is being used up by organisms. And then you can see during the fall and winter, nitrate comes back up to around 6 to 8 milligrams per liter. 10 milligrams per liter is the EPA drinking water standard. Another pattern with the concentration, those top 2 panels, is you can see it's very consistent in both 4 Mile and Walnut. The highest concentration is always at the agricultural site, secondly at the suburban site, and finally our urban sites have the lowest concentration. When we look at load, we can see there's some especially high loads during those storm events with thousands of kilograms of nitrate flowing down 4 Mile and Walnut during summer rain events, just flushing that off the landscape. And then finally, when we look at yield, we can see that the pattern again demonstrates that the agricultural sites are contributing the most nitrate per hectare relative to the suburban and urban sites. So I know nitrate's of interest to many municipalities in the metro, given the drinking water issues related to that. Next slide. So I wanted to just do a little comparison. So intuitively, discharge increases downstream. And what these panels show with 4 Mile at the top and Walnut on the bottom is if you take 100% of the discharge at the urban site, how much of that water was at the agricultural site that day when we measured it, and how much more did it increase by the suburban site? So we can think of what's the proportion of water being contributed by the upstream agricultural watershed, the suburban watershed, and then finally, how much more is coming into the stream by the urban site. So hopefully those data make sense. So in 4 Mile, we can see the average is about 15% of the flow at the urban site in 4 Mile is coming from the agricultural site, and 58% of the flow at the urban site is coming from the suburban site. Those numbers are roughly 1/3 and 2/3 in Walnut Creek. The reason I wanted to show this is that, Dylan, you can advance the next slide. It looks a lot different when we look at the nitrate. So now you can see the green bars are much larger for both 4 Mile and Walnut, with Walnut having the amount of nitrate at the urban site in Walnut, 90% of that was already in the stream. An average of 90% of that was already in the stream by the agricultural site, if we think about the actual mass of nitrate. So this does demonstrate that this suggests that the upper watersheds are contributing the majority of nitrate to our systems, though it does vary by date, as you can see. So these are sort of the analyses that I look forward to doing, especially as we have 3 years of data. Next slide. As we think about more people recreating in Iowa waterways with the Central Iowa Water Trails program, people are thinking about how to keep those people in the stream safe. And so E. coli is often what is measured. And the problem with E. coli is it takes several days to find out what's the E. coli levels today. We would know by Saturday. It takes 48 hours or so. And so people are trying to understand if we can develop relationships between E. coli and other measures of the stream that we can do in real time. One of those real-time measurements is turbidity, or how cloudy the water is. Often that cloudiness comes from sediment. And so here we're looking at the relationships between turbidity on the x-axis and E. coli concentrations on the y. These are both log scales. So I'd note that most of the samples we took were above the EPA recommended limit of 235 units per 100 mils. And the relationship with turbidity was good for some sites, like in Walnut Creek, the urban and suburban sites. The highest E. coli readings were also at the highest turbidity readings. But if you look at 4 Mile, the highest E. coli readings were actually sort of in the middle range of the turbidity readings. And then it actually E. coli tailed off as turbidity continued to increase during some events. So there is no silver bullet to understanding whether water quality is safe or not that we can get in a very short, real-time sort of fashion. Next slide. I did just want to share a little bit of metabolism data, and I know that I'm running a little short on time, so I'll just say that as we all have metabolisms, we need to take in food, and we use that food to have energy through the day. We can think of the metabolism for an ecosystem too. Ecosystems create energy. That's what all the plants there do. So in the streams, think of algae, and that's gross primary production. How much energy is produced in a day? And ecosystems use energy. All of the fish, the bugs, the bacteria, just like us, are respiring. So they need to take in energy to function. And the way we do this is we measure oxygen concentrations throughout the day. You can see that nice up and down pattern of oxygen. These are data from Walnut. And that allows us to estimate production and respiration on a daily basis. Next slide. In short, what this allows us to do is estimate whether the stream is in a healthy range, which is below the dashed line. You can see that the low values represent healthy production and respiration. And then the values between the two dashed lines on each panel represent satisfactory health. And then any days where you go above the red line on any of those panels, we have poor health. So I know that there's a lot going on here, and that's why I do encourage you to reach out to me if you want to chat more. I have a whole semester-long class on stream ecology. But what I wanted to just share is that if you look at the production represented in blue, and again, 4 Mile on top, Walnut on bottom, and across we have agriculture, suburban, urban. So production is in blue, respiration is in red. The thing to think about is that too much production is not healthy. So think of a stream full of algae. That's not a stream you'd want to go in. So too much production represents poor health. next slide, just animates in that when we look at the agricultural sites, we see that in the spring and summer, there are days where we exceed what we would consider a healthy range of production. So a lot of sun, warm water, algae are going nuts. So we'd say that those streams, from an ecological standpoint, exceed that health range. Again, this has nothing to do with human health, but more so ecosystem health. Next slide. And then we also see that there's differences in sites. So in 4 Mile, the 2 red circles at the top, we can see that this past spring, both the agriculture and suburban sites exceeded the satisfactory or healthy range of production, whereas Walnut Creek, neither of those sites did. So those remained within the satisfactory health range. So I'm really excited to dig more into these data as well. Next slide. So what has 1 year taught us? We found that some metrics are really consistent across sites and seasons. Think of nitrate, think of chloride. We saw the same patterns no matter which stream we were looking at, and they really varied by season as we'd expect. Some metrics varied by land use type, again, like nitrate, like the metabolism I just shared. Some metrics had apparent patterns at some but not all sites. So think about the E. coli and turbidity patterns I shared with you, that it seemed that they were related in Walnut but not in 4 Mile. And then finally, those metabolism data suggest that 4 Mile and Walnut were in good to satisfactory ecological condition for much of the year, which I actually found somewhat surprising, knowing how agricultural, suburban, and urban these landscapes are. I just wanted to share, next slide, 2 more slides of some exciting work that we're doing using an aquatic drone, again in these watersheds, trying to explore water quality by the minute and meter, so very fine scale. Next slide. I knew there were some engineers on this call. So we've got this drone outfitted with water quality sensors, and that screenshot in the lower right is what I can see on my cell phone in real time as this drone is going down a stream, as you can see in the image on the right. This work is in collaboration with the Department of Energy and my colleague at Oak Ridge National Lab in Tennessee. Next slide. So what we're able to do, this is Alleman Creek, a tributary to 4 Mile Creek. What we're able to do is we're able to measure nitrate here, as well as multiple other parameters, conductivity, turbidity, oxygen, temperature, at really fine scales. And I just wanted to point out the differences we see in just a week. So first of all, if you look at these 3 circles I provided, you can see where the tile inlets are. The range of nitrate we measured on this day was from 10.8 to 12.5, so relatively narrow range, but you can really see how heterogeneous or variable nitrate is across 2 kilometers of an agricultural stream. So if you look in the circle letter C, you can see 2 hot spots of nitrate. So those are 2 tile drains. You can also see around the B, circle B, that there is a lot of nitrate right at that 90-degree bend. And now if you advance the slide for my final slide, looking just a week later, you can see now B at that 90-degree bend has some of the lowest nitrate, whereas circle A at the top has quite a bit of nitrate. And then down in C, you can still see those tile inlets. So Dylan, if I could just ask you to toggle back and forth just to show how that varies. It's amazing to see how does the nitrate change at such a fine scale. And this is research that we'll continue to do for the next 2 years. What's really exciting about the reach of Alleman Creek that you see right here is that John Swanson and our colleagues with the WMAs are putting in multiple saturated buffers along this reach. So next summer when we go out and do this, all of those tiles will be gone. There'll be saturated buffers. We'll get a really good idea of how does conservation improve water quality, again, at a super fine scale. Final slide should just be questions. I took up quite a bit of your time. It was hard for me to distill some exciting stuff down into just 15 minutes, so I apologize for that. I wanted to provide some good context. If there's any brief questions, I'm happy to take them. Otherwise, there's my email contact one more time. And I'm very enthusiastic about streams, so please reach out, and I'd love to continue the conversation online, via email, or on the phone. Thank you.
Any questions for Dr. Levi? All right, thank you very much. Appreciate the information, and it'll be exciting to see what those saturated buffers do.
Absolutely. Thanks much for the opportunity to chat with you all today.
You bet. All right, moving on to the next item is a report and vote on the fiscal year 2021 to 2024 Transportation Capital Improvement Program.
Thank you. You should have all received a draft of the 2021-2024 TCIP. We meant to get that out with the agenda, but I was having issues with GIS and InDesign working remotely, so it took a few more days. Since sending that out, staff comments have made a few changes to the report, and so we'll be sure to send you a new version of that. A couple changes of the report this year from last year is that we are now tracking hazard mitigation projects. But after a few conversations, we decided that these projects shouldn't probably go into the overall total funding for projects, but instead it'll just be something included in the report, but not compared to our roads projects or intersections or traffic safety. But just know that it is something that we are tracking and will continue with the TCIP, but we won't compare it to the other sorts of projects. And then also this year, we had a couple more jurisdictions submit data than last year, and so our numbers are a bit bigger this year, but it doesn't necessarily mean that we're spending more money on these projects. It's just we had more people submit projects to us, which is great. And so I'll just briefly go over the overview of projects, project funding, and then show you the project map and talk about the EJ area spending. Next slide. So this is just the table of the communities that submitted projects to us and a breakdown of where they're spending this money. So again, we do have hazard mitigation in here, but we decided not to include that in this matrix, but it is in the report at the end, it's the final section. And then we had a couple communities not submit projects. So compared to last year, we had $131,037,060 more this year in spending than last year, which again, probably because we had 2 additional jurisdictions submit projects. Next slide. And then the funding by project type, again, it's pretty much the same as last year, except for our 3 big categories for spending for the next 4 fiscal years. Of course, roads continue to dominate where we're spending these funds, but bridges and then pedestrian and streetscape projects jumped up, whereas last year it was intersections and pedestrian streetscape projects. Next slide. Funding by fiscal year. This is, again, taken with a bit of a grain of salt, of course, with coronavirus affecting some of the budgets and things for communities. I think a lot of communities just estimated when these projects would happen, but of course that might change depending on how the rest of the year goes and things like that. So it looks like we're going to be spending a lot of money in 2023, but I think that that's just because we're estimating at this point when these projects will happen. Next slide. And then of course the projects map, which will be available on our website. Once as I do some of the table joins here, you'll be able to use this map in real time to zoom into these projects. But I did want to note that any projects that were submitted as citywide or various locations that weren't specified where these various locations were, of course I didn't map. Most of those were traffic safety projects, so communities that are doing a bunch of signal improvements. Those are not mapped. And then with that also, when I calculated how much money we're spending in EJ areas, I can't necessarily discern that a citywide project that's partially within an EJ area, what the exact number of funding would be in that. And so take this with a grain of salt. There are a lot more projects happening. And then of course, some things, if you zoom in, a lot of roads are new. And so if I didn't quite get the location of where these new roads are being constructed done, please let me know, and I am happy to fix those. A few communities submitted shape files with this data, which I really appreciated, but otherwise, I used my best judgment to find where these projects are going. Next slide. So with the EJ areas, last year, our EJ areas are calculated if a census tract has 6 out of the 7 degrees of disadvantage that we use, then it is considered an EJ area. And about 16% of the region's population lives within EJ areas. And like last year, 11% of all the funding reported for the TCIP report will be spent within these EJ areas. Which again, taken with a grain of salt, because citywide projects, I couldn't necessarily calculate for those. So with that, if anybody has any questions, I will be happy to take them, or if you have any suggestions or edits, feel free to email me or any other staff with those. We will be sending this to exec and policy for their approval as well, and so the report might look a little bit differently when it's finalized.
All right. Any any other questions? If not, looking for approval of the TCIP.
This is John Dostart. I'll move to approve the TCIP.
Second, Huesman.
All right, we have a motion and a second. Any further discussion? Anybody opposed to the motion? All right, we'll consider it approved. Moving on to the next item, which is the ICAP program pre-application. Zach.
The pre-applications were due on July 28th. In total, we received 6 applications, which are listed on the screen before you there. We also included a table in the agenda packet that provided a little bit more detail on project description for each of these projects. But Des Moines, Norwalk, Dart, Altoona, and Ankeny, and I believe Grimes, which is not showing up on this list, all submitted applications for ICAP. There was a little over $4.3 million in ICAP requests. Next slide, please. The timeline moving forward, we'll bring these project applications back in September for the committees to approve. Once the policy committee has approved them, we'll have a resolution for each of the projects, which we will send out to the project sponsors. And that way they can include those resolutions in their final applications that they will submit to the Iowa DOT by October 1st. So those are the 6 projects that were submitted. If you have any questions about the projects or the process moving forward, I'd be happy to take those questions this time. Otherwise, this is just here for information at this point.
All right, any questions for Zach? All right, if not, we'll move on to the 2019 travel time reliability and freight reliability report. Z.
Thank you. Next slide, please. Thanks. In 2017, the Federal Highway Administration finalized a series of performance measures for state DOTs and MPOs to report. Of these performance measures, there are system performance measures and freight performance measures. Under system performance measures, there are 2 categories. The first is called interstate travel time reliability. This is measured by the percentage of person miles traveled on the interstate that are deemed reliable. The second measure is the non-interstate national highway system, or NHS, travel time reliability. This measure is defined as the percentage of person miles traveled on the non-interstate that are reliable. In terms of system performance reliability, this is measured as the 80th percentile travel time divided by the 50th percentile travel time. And for freight performance, this performance measure is measured by the Interstate Truck Travel Time Reliability Index. And reliability for freight performance is defined as the 95th percentile travel time for trucks divided by the 50th percentile travel time for trucks. Next slide, please. So these system performance measures and freight performance measures relate to the MPO's LRTP goal number 1 to manage and optimize the transportation infrastructure and services. Within Chapter 2 of the MPO's LRTP, we provide the 5-year targets and also the 2050 targets for these performance measures. Next slide. So taking a look at the MPO's 2019 performance for these 3 measures versus our 5-year targets and the 2050 targets. In terms of the 5-year targets, the MPO was able to meet 1 of the 3 measures. And in terms of the 2050 targets, the MPO was able to meet 2 of those 3 performance measures. A quick note on the 5-year targets. You'll notice that the interstate reliability for the 5-year target is set at a very high aspirational target of 100%. It's rather difficult to always perform at such a high level. And if you look at the MPO's performance over time for the interstate reliability measure, performance has still been very high, just not at this very high 100% level. So it should be rather okay that we continue to perform at a high level. Next slide, please. So taking a deeper look at each of these performance measures, starting with the interstate travel time reliability, the MPO set a 5-year target for this measure at 100%, as I mentioned earlier. So the MPO was able to meet this target first in 2017, but then not in 2018 and not in 2019. In those 2 years, the performance was at 99% and 97% respectively. So performance was still rather high, just not at the extremely high performance level of 100%. And for the MPO's 2050 target, this was set at a 95% level, and the MPO has been able to meet this target in all 3 years since 2017. Next slide, please. The next measure is the non-interstate travel time reliability. The MPO's 5-year target for this was set at a 66%, and we have been meeting this target since 2017. And in terms of the 2050 target, this was set a bit higher at 75%, and the MPO has also been able to meet this target since 2017. Next slide, please. Lastly, our last measure is the interstate truck travel time reliability. The MPO's target for both the 5-year and the 2050 target is set at 1.28. The MPO has been meeting this target in 2017 and 2018, but then in 2019, the MPO performed at a 1.33 level, which is only slightly higher than the 1.28 level. This difference is only a little bit, and so it shouldn't be too alarming. Performance is still rather good. Next slide, please. So the MPO is now continuing on a more regular schedule of reporting these performance measures out to the various committees. Once we receive the latest and most updated data for these performance measures and others, we'll continue to report them as we receive the data. So with that, I'll be happy to take any questions you might have on these performance measures. Thank you.
All right, any questions for Z? If not, we'll move on to upcoming events. Shreyoshi.
Yes, good morning, everyone. This is just for your information that there is an upcoming conference opportunity that some of you or your staff might be interested in. It's the Mid-America Trails and Greenway Conference. This conference has gone virtual this year. It's on August 18th, and there's only 2 scheduled talks that are part of this virtual conference, and the registration is free. So if you are interested, please visit their website, maytag.org, and register for the conference. That's all. Thank you.
All right, thank you. Is there any other non-action items of interest to the committee? I believe Allison has one.
Yep, there is. I know a lot of you already get the DLAN listserv, but just wanted to double back and make sure that everyone was aware that there are a couple different hazard mitigation funding options through FEMA that are open. Both use 75/25 and cost sharing, and the most, earliest deadline is to have your submissions go through Iowa Homeland Security before going to FEMA, and that deadline is by December 31st. If you don't get the DLAN emails and you'd like the details on this, feel free to reach out and I can send those along. Thanks.
All right, thanks, Allison. Any other non-action items of interest to the committee? If there's not, we'll consider this meeting adjourned. Thanks everyone for the time.
Thank you.